I think you can able to see this material testing lab. This is for third semester and fourth semester. Now the B and section, B and C sections, for B and C sections, you people have this material testing lab. However, we are discussing this material about the materials regarding the material science chapter. Regarding the materials and the material science, it is in the third semester. Already we have been discussed in third semester material science. Whatever the things we have been discussed in material science theoretically, all the theoretical aspects are here executed. This total, this entire material testing laboratory is depending upon what we have been discussed in theoretically in our classroom the previous semester. So based on that, here we are going to conduct some experiments practically. That is the theoretical things. Whatever the theoretical aspects you discussed earlier, that will be executed here by practically. But however, we don't have that opportunity to conduct practically because of the pandemic issue. So we are in home. We all in home. So that this and we are at least we are trying to take even to the virtual labs. Before going to the virtual labs, how we are going to conduct the experiments, I will tell you everything about the experiments and how to conduct the experiment step by step. In further classes, I will explain you to how to conduct the experiments. Before that, we look into the syllabus of this MT lab. So here you know very well about the CIE marks, means internal marks is 40 and external is 60. Right, the course code is 18 MEL 37, not 37. 37 is a previous semester. Now it is a 47A. Right. These are the course learning objectives. To learn the concept of the preparation of the samples, to perform the characterization such as a microstructure, volume fraction and shape of material, as well as the grain size of the materials. To understand, second objective is to understand the mechanical behavior of various engineering materials by conducting the standard test. So already you have been discussed in the classroom, I think, different mechanical behaviors of the different engineering materials. For example, mechanical properties. Just I would like to mention here some mechanical properties: hardness, impact strength, torsional strength, so shear strength, tensile strength. All these are the important mechanical properties that materials does. So we need to understand how practically we can get these values of this all the how we can get the, or how we can come to know how they are practically behaves. Theoretically we can able to understand, theoretically we can able to read in the whatever the things or whatever the definition is written in the book. So some people are wrote very fine definitions regarding the mechanical behaviors. So only we can read it and we can buy things, and only that is the imaginary things, whatever the things you gone through the theoretically. So that is this and it is that, that only the theoretical things, unless we are not conducting the experiment. So I think we will not get thorough touch with that particular experiments unless we are not conducting practically. That's what the practical things are very very important. Whatever the theoretical things we have been discussed in classroom, that is from the practical aspect or practical things. Once we conduct that experiments, then only we can able to write something theoretically. Practical is first, then the theoretical things. You don't think that theoretical is first and practical is next. No, the first the practical things is happens. Later we can able to write that experience, what we are how we are conducting, what will be the working principle of the each and every machines, what will be the parameters, how we can set the parameter, or how we can control the machines. So how we can get the particular value or particular behavior of that particular material. All these things are we need to carry out practically. We have to have that practical experience, then only we can able to write theoretical things, right? But unless we are not conducting the experiment, the theoretical things will be the imaginary things. That's it. Now the third objective is to learn the material failure modes and the different loads causing the failures. Okay, different loads are there, you know very well, being both semester students. There are different forms of loads are there. right? The compression loads are there, bending loads are there, shear loads are there, tensile loads are there, impact load is there, torsional load is there. So whenever this materials are comes under this such kinds of the loads, how the fracture is takes place. Or else once you can look into the fracture surface, you can able to understand, or you can able to predict, or you can able to determine what kind of the load is acting on this particular material. Once we look into the fracture surface, you can have that ability. Once you've gone through this practical things, definitely that the same things come across in your future, definitely you can able to understand once you look into the fracture surface. Sir, this is applied by something load, that is a compression load. Due to the compression load, this type of the fracture is takes place. Due to the impact loads, these kinds of the fracture is takes place. Just once you look into the fracture surface, so you can able to understand what kind of the load is acting on that particular sample. All these things, only we are conducting the experiments, then only we can get all these things. Otherwise, it's a very difficulty to learn the concept of improving the mechanical properties of materials by different methods like heat treatment and surface treatment, etc. Yes, also we have I think you might have discussed this heat treatment topics in your previous semester, I think. What are the heat treatment process? Before that, we know the purpose of the heat treatment process. Why should we gone through the heat treatment process? Why should we learn the heat treatment process? What exactly the heat treatment process? What are the purpose of the heat treatment? What will be the aim of the heat treatment? The main aim of the heat treatment is to improving the mechanical property. You know very well. Already you have been studied, and also you are past that semester. Hmm? So I think many of you people are clear these subjects. I think you know very well about this things, heat treatment process. But here, the unless in the theoretically we are just we are reading the definition. Is heat treatment is a process of or is the process which involves the heating and cooling the samples. Hence, we can get the improvisation, or hence we can get the mechanical properties, improved mechanical property in particular sample. All these things we have been wrote, and we have been discussed, and we have been read in the books. But here we need to conduct this experiment. How we need to conduct, how that arrangements is carried out, how we can follow the procedure to conduct the heat treatment process practically. What will be the temperature? How can I maintain the furnace? How can I control the furnace? How can I control the temperature? How can I cool them? What will be the cooling parameters? All these things, so we can have to have the practical things. Okay, so we are this is the virtual lab. We are trying to just I'm trying to explain you how to conduct the experiment at least. So once the lockdown is lifted, definitely that suppose we got that opportunity, definitely we can go for our laboratory. We will conduct the experiments, no doubt. So before that, we have to have this virtual discussion about this empty lab. Unless we are not uh, defining and highlighting the mechanical properties of the engineering materials, we have to have some discussion, practical discussions. Through this tool, we are virtually we can discuss the how the practical things are carried out in the laboratory. Later, once the lockdown is lifted, definitely we will conduct the practically in our laboratory. Definitely we all together we can conduct the experiments in the coming days. Let's have to have now some virtual discussion about the labs. I hope you know about the um, course objectives of this empty labs. Now this is the scheme already you know. So 60 40, 60 external, 40 internal, and 60 the question paper will be so setting for the 100 marks. So you have to attempt for 100 marks. Later that 100 marks will be reduced down to 60 marks. But your question paper will be 100 marks. Maximum marks of the question paper will be setting 100 marks. So you have to attempt for 100 marks. Later that will be reduced down to the 60. And those 40 marks are 40 marks solids. So you can able to get from the internal. So here we will give the 40 marks in internal. Content of this empty lab. There are two major parts, part A and part B. So based on the conductions which we are categorized the experiments, around about 14 to 15 experiments we have in this empty laboratory. In that we are categorizing part A and part B based on the conductions and based on the arrangements. So so we are categorizing the part A and part B. So here we have a part A. Part A we can call it as a minor experiments because of the arrangements and all the things. Looking into the arrangements and looking into the parameters, we are categorizing which are smaller experiments, which are bigger experiments because of the mass based. So part A we can call it as a minor experiments. So minor experiments in the sense simple experiments. Simple experiments we can able to conduct individually. Keep it in your mind. Part A, in part A we have all the experiments are simple experiments, and we can able to conduct these individually, or you need to conduct individually, single. So here we have part A, and that part A has one question in the examination, and part B also has one question. Definitely that question has two major questions. One is part A, the one question is from the part A, and the one question is from the part B, right? So part A is 30 marks, part B is 50 marks, because however the part A is a simple experiment and you need to conduct individually, so the marks will be 30. Part B is a major experiment, right? You need to conduct in a group, that each group contains a minimum 2 to maximum 4, right? That part B is a major experiments where while conducting the experiments we need a group of people we need to conduct that. Because of the major experiments we have to handle the machines, and we need to set the different parameters simultaneously. All these things, there are a number of activities we need to take while conducting the major experiments. So that the reason we are allowing for 2 to 5 peoples, 2 to 4 peoples together. Uh, together they can able to conduct, right? That major experiments has 50 marks, minor experiments has 30 marks. Now total 80 marks, right? The 20 marks per viva. So around about 30, 50, 20. Sum of all three is 100 marks. Hope you understand, everybody. I'm audible?
Yes, sir.
Yes. Any doubts regarding the scheme of evaluation of this laboratory? 40/60, that is first thing you should understand. Later the things is in you need to conduct the you need to attempt the 100 marks, because that question paper will be setting for 100 marks. So in that 30 marks for the minor experiments, 50 marks, the only two questions you may expect in the final examinations, right? Only two questions you may expect in the final examination, one which is from part A, whereas second one which is from part B. Part A is 30 marks, part B is 50 marks, and remaining 20 marks is from vice versa. Viva. Total 100 marks. Later, that 100 marks is reduced down to 60 marks. In part A, here I would like to introduce the experiments which comes under the part A. The preparation of a specimen for metallurgical examinations of different engineering materials. So preparation of the specimens for metallurgical not metallographical examinations. Metallographical examinations means here itself we need to know the compositions present in that particular sample. Suppose the sample is suppose that carbon or given sample, sometimes it is a cast iron, sometimes it is a steel, or sometimes it is any other alloying sample. So you need to understand, suppose it is an alloying element, means definitely that alloying content is added into that particular base. Hence you need to know the what are the alloying elements are present in that base materials, and also how much they are percentage, how they are distributing. We cannot get through how much percentage is there in that alloying content in that base material. We cannot able to get from the metallographic examinations. Only we can understand the different bases present in the particular material. This that's the things that we need to prepare the samples for conducting the microscopic test. microscopic test, aim of the microscopic test is to know the different phases present in the particular alloy sample. That's it. And how we will conduct this experiment later we can discuss. So here the examples: steel, gray cast iron, SD cast iron, brass, bronze. Brass, bronze are the alloying elements because these are the copper alloys. Brass is also a copper alloy, bronze is also a copper alloy. You know very well about this, how the brass are manufactured, how the brasses are processed, how the bronzes are processed. The combination of the copper and zinc, which we can call it as a brass, the combination of the copper and other any elements, tin or any other things which are mixed into the copper, hence the copper becomes bronze. So these are the alloying elements. Now here through the microstructure we can able to edit, because brass and bronzes are look like a, just I'm telling you the importance of the microstructure. Suppose just you can think, just I will give you two samples in your hand. The both the samples are look like same, but I will suggest you, I will instruct you, these two are copper alloys. In these two are the copper alloys. Here one is a brass, other one is a bronze, but look like their external appearance is look like same. Bronze and brass are look like same. Just I will give you the samples in your hand. Now I will ask you, out of these two samples, which is a bronze and which is a brass. So mute your mic always, so you make ensure that your mic should be muted condition. So definitely that suppose if I'll ask you, I will ask you, so both are look like a same. So in these two, one is a brass and other one is a bronze. Then how can you find out? But look like both the samples are same. Their external appearance is same. Then how can you find out which one is a brass and which one is a bronze among two? It's very difficult to identify with our naked eyes. Hence, we need to take the help of metallographic or SEM, scanning electron microscopy. Through that, we can able to identify because copper and zinc or copper and tin are look like a different in colors. We can able to identify the different phases once we gone through the metallographic test, so that we can categorize the phases. So there are two phases. One is definitely one is almost copper is look like a darker in color. Some zinc is look like sometimes it is a lighter in color. So lighter regions we can call it as a zinc, and darker region we can call it as a brass. Hence we can able to understand there are two components are present in the alloy. For this reason we need to conduct the microscopy test. The heat treatment, as I told, and microscopy is a major experiment. Sorry, is a minor experiments. So for 30 marks. Singly we need to take a simple experiment. You can collect the samples and go for the electronic microscope. With the help of the electronic microscope, you can examine the phases. Now coming to the heat treatment process. Heat treatment process, already you know very well about the heat treatment process. Here we can give you a sample. You can go through, take the samples and go through the according to the procedures. You can heat the samples and then cool the samples. Then you can check the hardness values of the particular sample. Right? Before keeping into the furnace, before keeping into the furnace, we need to know the initial hardness of the sample. That's, don't forget, that is very important. Once we collect the sample, we can go for the hardness test. We can check the hardness value of that particular. Then you can heat it and cool it. Then you can collect back. Again, we need to check the hardness. Right? Then you can compare the hardness values of the initial and after and before hardness values. If it is increases, you can write it is increases. It is the end result, you can write the hardness value is increased from here to here. Or if it is a decreases, you can write the answers. The hardness value is decreases from this to this, whatever it is, no problem. So the heat treatment is also one of the minor experiments, and the students shall be able to distinguish the phases changes in the heat treatment. That is the things I told you that. And the one more is Rockwell and Benil test. This is the procedure. Again. Yes. And here the hardness test. Third one is the hardness test. Hardness test also a minor experiment. Here there are three types of hardness testings. One is a Benil hardness, second one is a Rockwell, and third one is a Vickers. There are three hardness experiments. All the three, the aim of all the three experiments is the same. We need to determine the hardness value of the given sample, right? So here we have a different named equipments. We can use these equipments or machines to determine the hardness value of a given sample. This is also you need to conduct individually per 30 marks, right? And one more experiment. So non-destructive testings, and one more is there, wear testing. Wear testing is also comes under this minor experiments. Wear also it comes under minor experiments, which is also 30 marks. One more non-destructive testings like ultrasonic flow detection, magnetic craft detection, and dye penetration test. These are the non-destructive testings. There will be a lot of difference in the destructive and non-destructive testings. Destructive testings means we can we need to break the samples, or we need to damage, or we need to harm the samples unless we will not get their strength. Once that material, just let them to under suspension of the load, any kinds of the loads, till the fracture we need to wait. So where exactly at what point of the load the sample will be break, or sample will be harm, or sample will be damaged. At that load we will collect, and then we can calculate the strength. So these are the destructive strength or a destructive. Destructive means we have to break the samples, then we can get the results. Break the samples, scratch the samples, or harm the sample in any manner. Non-destructive means without affecting the samples, without affecting a given sample. So we can carry out the test over the sample, and we will take the examinations without harming the samples, without any type of the harming. So we can able to conduct the test, then we can get the results. This is, we can call it as a non-destructive, without destroying, without affecting, without harming the samples, we can able to get the results. So in that there are three experiments of ultrasonic flow, magnetic craft detector, and dye penetration. Ultrasonic flow, so and in our laboratory we have a two there are two experiments are available. One is a magnetic craft detector, and other is a dye penetration testings. Definitely, so once we reopens, the college will reopens, definitely we are going to conduct these two, magnetic craft detector and dye penetration at that time. So I will not at that time, so the incoming classes I will explain how to conduct the magnetic craft detector and dye penetration test. But first, just I am telling you the phenomena of non-destructive testings now. So, okay, this is also comes under the part A, so is Barama 30 marks. Now coming to the part B. So part B, here we have a major experiments around about around about 5 to 6 experiments we have been we need to discuss, and this will be the 50 marks question. So here number one, tensile test. Definitely we need to conduct the tensile test. So you need to conduct in group system, at least 2 to 4 people are in the group. So you combine together, or you all together, you need to conduct the experiment. So tensile test, shear test, compression test for different kinds of the engineering materials: steel, aluminum, and cast irons. Maybe the examination anyone, either they can give you the aluminum, steel, or cast iron. So in practice lab, so we have to make ensure that we need to practice all these three different materials. For tensile test especially, shear test, any one of the, in the practice lab also we will give any one of the samples. In the final examination also sometimes we will give the cast iron and steel, but the tensile test is one of the major tests. We need to take all these three materials. We have to have that practice. Tensile, shear, compression of the all are the major experiments. And also bending is missed here. That bending is also is there. Shear, tensile, compression, and bending. So all these four experiments we need to conduct in universal testing machine, UTM. So we need to take the UTM machines, because these experiments are executed in UTM. universal testing machine. With the help of the universal testing machine, we can get the all these results. And torsional test is also one of the major experiment. So we need to conduct the torsional test. So we will discuss later in detail in the torsional test also. Especially we are using the mild steel for conducting the torsional test. And here we have bending test, right? So bending is already I told you the bending is also one of the major experiment. So sometimes we have steel and wood samples which we are using for bending, and also compression. Most of common compression also we are using these some steel materials as well as wood materials also we can use to conduct the compression test. And so fourth one is ISOD and Charpy test. Definitely here we have two impact tests. This is the impact test. So in impact test we have two methods. One is the ISOD method, other one is the Charpy method. Right? Again the material we are now using the cast iron or mild steel material, anyone. So which is available we can take that and we will conduct the experiment, or we need to practice that. Right? There are two methods in the impact test, Charpy and ISOD. Coming to the fifth, to study the wear characteristics of the porous and non-porous materials under the different parameters. So see here I am telling you that wear test. So the unfortunately wear test they are showing in B part, but it is a very simple experiment. Hence we can take this experiment into the minor part. The wear test will comes under the minor experiments. You need to conduct this wear test individually. Why they are taking in B part? Because that is depending upon the arrangement. Sometimes we are test, sometimes we need to take the simple arrangement, sometimes we may take the complex in arrangements. That is depending upon the laboratory, right? That's what they are showing in part B. In our laboratory we have very simple construction for conducting the wear test, hence we can take this experiment into the minor part, right? And now fatigue test is that this is only demonstration. In our laboratory we have a fatigue test also. Just we will give the demonstration about this fatigue test. So how we need to conduct the fatigue test, what will be the parameters, and how we need to set the parameters, right? I hope you understand part A and part B. Round about here 6 and round about here 4 totally. So because here we have a two experiments in ISOR and test, ISOR and Rockwell. In hardness test we have three experiments. In impact test we have two experiments. Around about total 14 experiments. I think we can expect at least we need to conduct 14 experiments in this semester, right? In that out of 14, few are comes under the part A and few are comes under the part B. Whichever experiments comes under part B, which are all major experiments, whichever that comes under part A, which are the minor experiments, 30, 50 and 20. So these are the outcomes at the end of the course. So we can able to get these kinds of the knowledge to acquire the experimentation skills in the field of material testing. At the end of the course you can able to get all these things, all these outputs. The development or develop the theoretical understanding of the mechanical properties of materials by performing experimentally. I told you that at the beginning only. Apply the knowledge to analyze the material failure and determine the failure inducing agents, and apply the knowledge of testing methods in related areas in your future. Understand how to improve the structure behavior of the materials in the various industrial applications through the heat treatment process. At the end of the course you can able to get all these things. Once again I will show you the scheme of evaluation. That one question part from part A is 30 marks, that one question from part B, that is 50 marks, the vice versa 20 marks, total it is 100 marks. Is there any doubts?
No, sir. No, sir.
Is there any doubts? You can ask me. No problem. Beginning itself only, because once we gone through the experiments, again we will not come back to these things. You don't ask again and again, sir, what is minor and what is major experiments, and you don't get in at the time of the examinations, right? So we remember which is a minor experiment, which is a major experiments. That's very important, right? I hope you understand these things, right? No doubts. It's clear
No,
now?
sir.
Okay, now I will.
Yes, sir.
Okay, so now this is the about syllabus. I have told you that. Now we will discuss how to conduct these labs in virtually and how to discuss virtually about all the experiments. So give me a 2 minutes. I will take you into the virtual class. We will discuss another 5 to 10 minutes. We'll wind up the class. Tomorrow you can inform your friends. We will start the experiment. And, the one experiment we will discuss today. That then only they can understand. Otherwise, the people cannot understand. Give me 2 minutes. Right. Yes, can you able to visible slide or screen? Yes, yes, it is visible.
No, sir.
No, no. Yes, someone is saying yes. Someone is saying no. No, you can wait for a few seconds. Definitely will. Now is it visible, everybody? Say loud. Say it loudly. Yes or no?
Yes, sir.
Yes,
sir.
right. Yes, thank you.
No,
Yes, sir.
Yes, sir.
Everybody saying
yes,
yes.
sir.
That one student is saying no. The problem is your side because we all get it, but just check your network. Hmm? Maybe it is poor. I think. Okay, everybody able to visible this, right?
Yes, sir.
Okay, now the virtual labs. See, so this is the design of the virtual lab. The welcome to the strength of materials or material testing. It is. So there are some different universities are giving different names. Don't worry. So, so this is our window of the virtual lab. So here we have an introduction about the labs, the list of experiments. After the class, I will give you. After all the experiments, I will give this virtual lab ID. You can access. I will give the web address of this virtual labs. After the experiments, you can access these virtual labs. No problem, right? Introduction. It starts from the introduction about the all the experiments or introduction about the lab. These are the list of experiments. So targeted audience means who can understand, who can discuss, and who can study this lab. That would here they are writing. And course elegance. This is none of our business. So prerequisites and feedbacks. This is also not need. So do not need all these things. Now we will look into the introduction, dear students. See, introduction already I have opened here. So the strength of materials are that is what we can call it is an behavior of engineering materials is the body of knowledge which deals with the relation between the internal forces, deformations, and external loads, etc. This laboratory provides the basic knowledge of strength of engineering materials. Strength of engineering material with respect to all the aspects, strength of materials, and here the students can perform the different tests on different materials. I hope you understand. Definitely, the people are asking, or maybe the examiner, the external examiner, maybe they can ask you. So tell me about your lab. What's the importance of this empty lab? The very simple question it is, or it is the first question, right? Definitely they may can ask you. So what do you mean by the empty lab, or tell something about your empty lab. See here we have answer. This laboratory provides the basic knowledge of the strength of all the engineering materials, and here you can able to perform a different tests on different materials. Hope you understand, everybody. You can able to perform practically. Now we are discussing virtually because of the pandemic issue. Please, if it is not a pandemic issue, definitely we would have conducting the 2 to 3 experiments right now. Let it be no problem. See, the answer is here. The laboratory is provide the basic knowledge of all the engineering materials. Also, you can able to perform for the different tests which are listed here, and also in a different kinds of materials. Right? I hope you understand about the introduction about this lab. Yes, is it clear or not, everybody? Now, so we'll move on to the list of experiments. So here, so this is in a particular virtual lab. Here we have almost 80% of tests we can carry out through this virtual lab. So this is the list of experiments. Can you able to see? IJOR test is there, Sharpie test is there, shear test is there, shears test of the wood materials, shear test of the mycel and other plates, and hardness tests are there. So Rockwell hardness is there, Vickers hardness is there, bending test is there, tensile test is there for different materials, compression test for different materials, and torsional test for the moisture materials. So remaining experiments we can conduct in our laboratory. Right? So at least 80% of experiments are covered through this virtual lab. Remaining experiments we can directly connect. We can able to conduct in our laboratory once the lockdown is lifted. Right? See, this is the list of experiments I have shown you. So targeted audience means we only can the primary, pre-primary year students, Bachelor of Engineering and Civil, Mechanical and Civil, both people can able to study this lab, right? Okay, now I will move on to the first experiment. Shall we take the Rockwell test, hardness test? Yes, Rockwell hardness test. We will take the first experiment. The Rockwell hardness test is a minor experiment. Just I will give you another 10 minutes. I will give you the introduction about the Rockwell. Right? We will finish one experiment so that other people can alert. So Rockwell hardness test. Before dealing this, I would like to ask you something about harness. What you mean by harness? Please see, this is the virtual lab, means it is a practical lab. So we have to have that discussion. Unless it is again, it will be the theory class. Whatever it is, right or wrong, you can guess the answers, no problem. Feel to discuss, no hesitations. You can give any type of answers, no issues, right? Whether it is right or wrong, just as per your perception or as per your idea, you can give the answers, no problem. Don't hesitate. So tell me what you mean by harness. Hello, please, anybody? Ravina?
No, sir.
Any?
No, sir.
So harness already you have been discussed in your theory classes. Definition of harness. Nobody knows. What is the definition of the harness? Because only if you know the harness of the definition regarding, so at least you know the definition, at least. So based on that definition, now we will conduct the experiment. what you have in theoretically, then we can execute that practically. Now we can tally the answers and we can tally the concept whether it is right or wrong. So, right. What do you mean by harness? See, the harness represents the resistance of material surface abrasion, scratching, cutting. Harness after the giving clear indentation. Simple definition it is. Harness is the ability of the material to resist the indentation or penetration. Am I right? Hmm? Ability of the material to resist the indentation
Penetrate.
or penetration, or else suppose the indentation or penetration are difficult words for you, you can say easily the ability of the material to resist the abrasion, scratching, cutting, right, or some any other flaws or any other irregularities in the that we resist these kinds of the phenomena, that we can call it as an the harness. For example, I will give you. So kindly mute your mic. See, Shashi Kumar. Shashi,
Yes, sir.
what do you mean by harness?
I love mathematics, sir.
Hmm? All cleared, right?
Yes, sir.
Then tell me what do you mean by harness? Hmm? Then it is waste now.
Yes, sir.
Hmm. See, the harness here only here we are writing. Simple definition it is the ability of the material to resist the indentation and penetration. Just I would like to give an example for the harness so that you can understand better. We all have to have that practice to wear the wristwatches. For example, fast track wristwatch is there. Everybody are looking for the chain watches, right? Not belt. Some people are not interested in the belt because the belt are there will be the problem in the belt, or the poor quality of the belts, and durability of the leather will be less than the steel belts. Most of the time the fast track watches are made by the steel materials, right? We are that's for the reason we are looking into the fast track watches which are in a chain wrist watches, chain lock wristwatches. Just look into the surface of the chain as well as the dial. See that dial and that wristwatch chain is made by the harder materials. Why? Because anyone can tell. What is the reason the peoples are using that steel materials, stainless steel? You might have observed that at the bottom of that chain, there some people, or bottom of the dial, there will be the uh, there will be the print over the seat, bottom seat, stainless steel, water resistant, like this they are writing. You might have observed that the stainless steel. The why? Just to think why these chains or why these dials are made by the stainless steel only.
Corrosion
It is
resistant.
harder, sir.
Yes, sir, 100%. Because why we are using the stainless steel for making the body of the wristwatch? Because stainless steel is a hard material that will not allow to get these scratches over that. That will not allow easily to get a scratch, because here we are we are continuous 20.7 we are wearing that watch. While wearing only we are playing, we are sleeping, something we are doing, right? But we are not we are least bother about the watches. Just we are playing, even we are wearing it, and while wearing only we can play it, we can sleep it, and no, we are least bother about the watches because we know that they are stronger and harder. If that surface is not made by the stainless steel is a harder material, right? If that body is not made by the stainless steel, what happens? Just you can think, what will be the situation if that body is doesn't made up of stainless steel? Then what will be the reason and what will be the situation? If it is not hard, a single day, in one day you can get a number of scratches over the dial. If it is not hard, then that cannot resist the scratching. If it is hard only, that can able to resist the indentation, penetration, scratches, cutting, all these things. If the dial is not made by the harder material, then we can expect the scratches over the dial. In a single day, we can expect 10 to 100 scratches over the, because we are involving in the number, the variety of the activities. We are least bothered about the watches. Number in day-to-day life, we are involving the different works and different activities, so that there will be the impact, and there will be the other load, or the sometimes environmental load. Then something will happens to the dial, but that we are least bothered about that, because that nothing happens to that dial. That's what we are least bothered about the dials, because dials are made up of harder materials. Harder materials will not let easily undergo a scratch and indentation and penetration. Hence, in single day we will not get any single scratches. You can wear it in a number of years, nothing will be happens. If one day we will get the 100 scratches or only minimum 10 scratches over the dial in one day, after a week, just you can see the situation of the dial. Simple case it is. I hope you understand the best. This is the best example for understanding the harness in industrial applications. So such a, you know, you can understand. So like that, we are using with some equipments and tools which are made by the harder materials, because if even that material will not allow the scratching and indentation, then that will not easily break. Even the single scratch, then that break point will be, fracture point will be there more, right? So this is the theory is there. So we will not take much time for theory. Theory we can, you yourself you can read, but only the things now which are important, that only I can highlight. This is the definition. I hope you understand. Everybody should understand the definition first, because the first question is arises in the mind, examiner mind. Definitely they can ask you, define the harness. If you are not able to define the harness, then he will not allow you to conduct the experiment. That's it. Even internal or external. If you are not able to define the basic property, then how can you allow conduct the experiment? That's it. So the so here there will be the procedure is there. This is the theory. So here something is writing there, the different scales are there, A B scales are there, and the 1 kg force, 150 kg, we can able to see that. Later we will discuss all these things. This also again this will be covered in our procedure, so no need to discuss in this theoretical things. Now I'm coming to the types of the Rockwell test. Only that Rockwell test, only type of the harness test in Rockwell test. In this test, the minor load about 10 kg and major load is about 60 to 100 kg, or maximum 150 kg is applied. So in this particular Rockwell test, there are two major there are two major loads. One is a minor load, other one is the major load, right? So I will tell you everything about the loads. Test ones. Right. See, coming to the load. Now I'm talking about the loads. Here there are two types of the loads we need to apply for the material. And before that, I would like to discuss here the procedure. So how we can take the procedure, sir. The first procedure I would like to share you. So collect the sample. So there are different types of the samples are available. The instructors will give you the samples. Maybe the sample is my steel, or may sometimes the cast iron or aluminum. Right, steel, aluminum, copper. There are three different samples which are available in our laboratory. The instructors will give you the samples. Once you collect the samples, you can go for the conduction. So while before conduction, you need to collect all the parameters. Which are the parameters? Major load depending upon the materials. So depending upon the material, so depending for aluminum 60, for mild steel 100, cast iron 150, depending upon the materials you chosen, you have been already chosen. Depending upon that, you can able to select the loads. So the minor, these are the major loads already which are in the machines. That beside of the machine there will be the point is there. You can set the loads through that. Right, there will be a point is there, 60, 100, 150 point is there. You can set the point, and this is the major load. And coming to the minor load, minor load means here I would like to explain here through this figure. Yes, this is the image. We can able to see the harness machine it is, which is a Rockwell harness machine. See here the loading device, as we can see, everybody can able to see this. So that the beside of the machine here, here we have one unit. This is a loading device or loading unit. Here the number of load sets are there. 60 is there, 100 is there, 150 is there. So based on your selected material, if it is aluminum, you can set 60. If it is a steel, you can set 100. If it is a cast iron, you can set 50. Depending upon the material, you can select the load. So once you select the load, so this is the hand lever. So once you set the load, you can apply the hand with help of hand lever. You can load. Just you can load it. See the load this side. Now it is in this direction. Now you can take this in a backward direction. Now the load is applied. Set the load, then you can, with the help of the hand lever, you can apply the load. Right, before applying the load, once you can set the load, then you can come here, take your sample and keep it upon the animal. Yes, this is the dial indicator. Right, this is the measure. This is the above part. This is the indicator or dial indicator. So we can, sorry, indenter, sorry, dial indicator is here. So this is the indenter. Indenter means here we have a ball indenter and diamond indenters. Indenter means that is a ball. Suppose it is a ball indenter, that is just look like a ball. It is a steel hardened ball. This is indenter holder. Here we have an indenter holder. In this indenter holder, we are fixing the indenter. Indenters are available in a different shape and sizes, which are made up of steel, hard steels. They are also available in the different diameters. Based on your type of the material, you can able to choose the indenters. Then you can set the indenter into the indenter holder. Then you can keep your sample upon the anvil. Then here we have a hand wheel. Just rotate the hand wheel. Rotate the hand wheel. Rotate the hand wheel. Now the hand wheel is slowly so rising. You can rise. You can rotate the hand wheel till this platform, this anvil. That anvil that here we are placing the workpiece. The surface of the workpiece and surface of the ball indenter is need to touches. Till that you can rise the pendulum. Sorry, rise the screen with the help of the hand. Once the surface of the workpiece and surface of the ball indenter are in close contact, you can stop. Right? Then you can note on the dial. You can check the condition of the dial indicator. Based on the type of the material, you can set the scale here. A, B, C scale are there. Now you can just once just touches the workpiece, just note on the dial indicator whether it is in proper condition or not. Once it is a proper condition, then again start rotating the hand wheel, because before it just touches the surface between the ball and surface between the workpiece, just now we are ensuring to that a small relation or small closeness. Hence, once this is the proper in condition, again you need to establish the, or you make ensure that the surface between the both workpiece as well as the indenter should be tight and very close. Then you need to apply some manual loads. Then you can turn the anvil, because we need to make ensure that The contact between these two surfaces should be very close. Hence, we need to apply some load by manually. That is what we can call it as a minor load. C. Now, definitely in the final examination, the examiner is asked you what you mean by minor load. Shashi, tell me what you mean by minor load now. Anybody voluntarily? Huh? Definitely in the examination, they can ask you what do you mean by the minor load and major load. Major load directly we can based on the type of the material, because at the here this is the portion is there. Here we have a chart depending upon the material. Here we have a depending upon the loads and depending upon the indenter. Everything will be in the chart that itself in the machine. Whenever you are coming to the practical laboratory, definitely that machine itself has a chart. In that chart everything is available: type of the material, type of the load, and type of the indenter, and type of the scale. Everything is available. Just we can determine what kind of the material so I have chosen. Once you got that, this is the cast iron, then you can come here, there will be the chart, the type of material is there. Here there is a cast iron is there. Through the cast, according to the cast iron, you can select the type of the load, so type of the indenter and type of the scale. That's it, simple case it is. But the thing is, what you mean by minor load and major load? Major load is according to the depending upon the type of the material, from the scale or from the chart we are taken, sir. That is what major load. Major load is depending upon the type of the material, sir. Simple case it is. Where you can get this, sir? Here the chart is there, sir. That is mounted over the machine, or that is itself in the machine. That is affixed to the machine, sir. From that machine I have taken that. From machine itself has a chart, sir. From that chart I have taken that major load depending upon the type of the material, sir. That's it. Suppose what do you mean by the minor load? So where you get it? How can you get this minor load? Sir, minor load means is around about a 10 kg to 15 kg. We need to apply by manually, sir. How you are applying the minor load? Sir, because we need to establish the close contact between the tip of the ball indenter as well as the surface of the workpiece. These two are should be in a close contact, sir. That's what we are applying some force by manually. We are turning the hand wheel or raising the screw. So hence these two are close in contact, sir. While doing this, we are applying some our energy, our manual energy, that will be approximately 10 to 15 kg, sir. 10 to 15 kg force. Hence, this becomes the minor load. I hope you understand about this major load and minor load. Tomorrow again I will discuss about this procedures. Already I have discussed step by step. We need to discuss the procedures of this Rockwell test, and also we need to discuss the chart. So here we have a tabular column and everything, how to calculate and everything I will tell you tomorrow, right? So now I will wind up this class, and just wait, I will take the attendance. And Sashi, you inform your other students, C-section students.
Okay, sir. Okay, sir. Okay, I will inform.
Can inform. See, the attendance is very, very important, right? Based on the attendance, your marks will be distributed.
Yes, sir.
ಏನಪ್ಪ ಎಲ್ಲರಿಗೂ ಹೇಳ್ತಾರೋ
Okay, sir. Okay.